control line. If it is not having this one, then we can use it for a dummy move. Similarly, you can design a DFA with same one that accepts string which is not starting with 1 or ending with 0. For this example, first one is we are starting with 1 and ending with, this is an AND operation. If we use De Morgan law with this one, then we can say that it will be accepted not starting with 1, that is 1 bar, or 0, that is complement of this string, and is converted to 1, this or, and 1 is not 1 and not 0. For this one we can do the same diagram, only the starting symbol state will be only the non-final state will be final state and final state will be non-final state. In this way we can design the same one. So this is an homework that you can do the diagram and you can check for this one. Now there are some more examples given here that can be solved in the classroom, that is design a DFA that accepts the string over summation, that is A and B, and it containing A, ending with A and starting with A. If it is containing A, then how we will be designing this? If it is ending with A, then also that same diagram that we have shown here in the earlier one. If it is starting with A, then how will be the output? If we design an ending with A, then end A will be at least one A, that is ending with A, that can have multiple A and A, it can have multiple B and A, and so on. It can have multiple A, multiple B, and so on. So this kind of language is for ending with A. Now if it is starting with A, so A must be there and then anything can be here. So if we design this one, then at least one A should be here, and this is Q0, that is starting with A, and we can write anything here. So it can have A or B, but it should start with A always. Now what for B? For this one it is completed because we have A and B here, we don't have B. For this one we have to make a dummy state with naming it as D for uniformity, and this will be the diagram. You can solve for containing A and you can solve for ending with A. Now this is a similar question, but the logic is a bit different. Once you solve for any divisible factor, then you can do this for any other number. So for this one, this is like a DFA that accepts binary language, and binary strings are those strings that's why the summation will be here 0 and 1, because binary, this has to accept only the binary string, and those are divisible by 3. Now by this question, how to formulate this type of question, this is an like important thing to consider. Now whenever we will be getting this kind of thing like divisible by 3, then we need to remember that we will be having number of states as that number, that is, for example, it is divisible by 3 now, so our like number of states will be 3. Now for this one, now which input will be go to which one, that also we need to check. For this one, if we have Q0, suppose Q1 and Q2, these are the 3 states, so which will be accepted state and which will be rejected state. Now if we have Q0, suppose we have a number 0 0, so this should accept or reject. Suppose it should accept because it is divisible by 3, because it has no remainder when we are dividing. Now if it is 0 1, it should not accept. If it is 1 0, that is also not should, it should not accept. Now if we divide it as 1 1, then it should accept, because again 3 is divisible by 3. If it is 4, then it should not accept, and the output should go to Q1. And if it is 1 0 1, the next alphabet, that is digit, that is 5, that next number, that is also not divisible, and the remainder we are here we are dividing the remainder as 0 1 and 2, because by whenever we divide a number by 3, there will be 3 remainder actually, either it will be having 0 or 1 or 2. In this way we are dividing this number. The next number can be of 1 0 1, then 1 1 0, that is 6, next is 1 1 7, then 1 0 0 0. In this way you can divide. Now to design with this one, we can consider this diagram, or up to this much number is okay for considering. Now suppose we have the initial state, that is Q0, it is showing that Q1 is the accepting state, because it is accepting all those numbers which is divisible by 0. So we can directly mark it. That is, when a 0 is coming initially, we should accept this. Now what will happen the next digit? Suppose we have already a 0 and 1. It should go to Q1 state, and it is obviously not the it is a non-final state. Now after that, now we have designed with 0 and 1. The next digit is 2. So 2 is by 1 and 2, 1 and 0, 1 and 0. This is also a non-final state, and it should reach to Q2. Now what is about 1 1? 1 and 1. It should reach to Q0. That means whenever we are starting with 1, and if we give another 1, then it should reach to Q0, and it is an accepting state. That means 3 is accepting here, 0 is also accepting. Now if we have 4, that is 1 0. Now we have another number of 0, and it should go to Q0. Sorry, it is 1 0 0, 1 0 and 0, that is Q1. Next is 1 0 1, that is 1 0 and 1, it will go to here. Next is 1 1 0, this is also an accepting status, that is 1 0 1 1 and 0. So it is accepting. Now for this one we can see both the transitions are completed, 0 and 1. For this one is also completed, this one is also completed, and it is a complete DFA. Now check for any string, it will be accepted or rejected. You can imagine by this one. Suppose it is an 8 and it should reject, and the output should reach to Q2. If we check this one, first we are going to 1, then 0 and 0, again 0, then it is going to Q2. That means it is rejecting. So these are some examples of DFA. Similar examples you can collect from net, and you can consider this one. There is another example of DFA that showing that even number of zeros and ones. The same diagram can be used for remaining 2 3 by changing this only the final and non-final state. So whenever we are having like this question even number of zeros and ones, first thing is that the minimum string it can accept is nothing, that is epsilon. Second string it can accept is now even number of 0 0 means it can accept 0 0. It can accept even number of 1, that means it can accept 0 1. It can accept 0 0 1 1. It can also accept 1 1 and 0 0. It can accept 1 0 1 0. So if we check by this diagram, so it can accept 0 and 0, it can accept 1 and 1, it can accept 0 1 0 and 1. So any number of combination with even number of zeros and accepts 1, this diagram can be accepted. Now coming to non-deterministic, till now we have seen all the deterministic example where del equal to del we can define as q into summation goes to q0. That is, whenever we are giving an input to a state, it should go to another state, and it is a mandatory, like for all the input we have to give the transitions. That's why it is deterministic. Now moving to non-deterministic, now we don't need to consider all for like all that string. We also see that epsilon moves for non-deterministic behavior. First we will start with normal non-deterministic, that is non-deterministic without epsilon move. For this one, what we have to consider, now suppose we have designed a diagram that is accepting a single alphabet, that is 1. So we will be designing suppose in this way, because if we give 1 here, then it is accepting more number of 1 as well, right? So if we have to design a language for language which is accepting only 1, so suppose this is the NFA for this one, so we don't need to, the summation was suppose on 0 and 1, so we don't need to think for 0. We are not considering like any input or things for this one. For this one 0, we don't need to consider, only the thing that is if there is one input by which we can get the suppose that expected output by at least one string. If we get the expected output, then it is accepted by NFA. That means here we have seen that from Q to Q1 we are from Q0 to Q1 we are going through by 1, and it is a final state, that means it is accepted, so we don't need to bother about other thing. Now for the same thing, if we design a DFA, the DFA will be different. That will be, now suppose we have given for this one Q0 to Q1 by 1 we have reached to Q2. Now we have to consider for this one where by 1 it will go, by 0 it will go to a dummy state, 0 and 1. For this one it has to also be like go to this dummy state. In this way the DFA will be there. Like that means that DFA is a complete transition.